In this lecture, I'm going to show you how to configure port address translation, or sometimes known as NAT overload. So with NAT, you either have static NAT or dynamic NAT, and this is dynamic network address translation. So in this topology here, there's a standard. There's two standard zones. There's an inside zone and an outside zone. So the inside network addresses are private addresses from RFC 1918, and they're not routable across the internet. In this example, 192.168 private addressing is assigned to host 1 and host 2. So there's an inside interface and an outside interface. The outside interface is assigned a public IP address. In this example, it'll be 172.33 addressing. So what port address translation does, it takes hundreds or thousands of private IP addresses and maps them to either a single public address or often a pool of public addresses. And by doing that, you can enable internet access based on just a single public address, or as mentioned, sometimes there's a pool of public addresses as well. So what I'm going to do is I'm going to start off with router 1, and I'm going to sign on. And start the configuration. So what I need to do, the first thing I need to do is define an inside NAT interface. And that'll be the inside private interface FA20 on router 1. So I'll go interface FA20. And I'm going to assign it an IP address, 92.168.1.3, just a default subnet mask. Next, I'm going to do IPNAT inside. That defines it as the inside private interface for purposes of network address translation. Then I'll do a no shut because it's a layer 3 interface. What I'll do is I'll go to the outside interface now, and that's interface FA10. I'm going to assign it an IP address, a public IP address this time, 172.33.1.1, and just a standard subnet mask. That's the IP address for that. And then this will be IPNAT outside. And then just a no shut to enable the interface. And state change to up. So what I've done here then is I've configured the inside interface for private NAT and the outside for public NAT. And port address translation will occur on router 1. So what I've done is I've assigned these two interfaces here. Now I'm going to create a pool called CCNA, and this is the NAT pool, and it's going to have public addresses defined. And as mentioned, you can use a single address or multiple addresses. So what I'm going to do here is I'm going to define 172.33.1.1 through 172.33.1.10. So there's 10 public IP addresses I'm going to define for the pool of public addresses that will be used to map from private addresses to public addresses. So I'll just paste this right over. And then just a standard net mask that both interfaces are using. That's just a /24. The next thing I want to do is I want to define an ACL. And this is going to be an extended ACL. It's called 100 numbering. And what it's going to do, it's going to tell router 1 what private IP addresses are permitted to be network translated to a public address. So in effect, what it does is it permits access to the internet. And for this example, I'm going to permit all 192.168 subnets, all hosts that are assigned to those subnets. So we'll just paste it in here, and that's easy enough. Then the next thing I'm going to do is I'm going to bind the ACL 100 to the public addressing. So what I do is here I say IPNAT inside source list 100. So that is effectively saying take any private IP addressing from this private address range of 192.168, so any host assigned there, and assign it to this NAT pool called CCNA and use overload. And the overload keyword, what that does is that assigns a unique port number to each IP address that arrives. So for example, 192.168.1.1 host will get a unique port number. So that's a unique network address, and it's assigned from, and it's actually being mapped to a single public address, but the public address thinks it's a unique network address. So what it does is it just translates it in and the same thing for any other session. You assign a you assign a port number. So what happens is the public address itself gets a unique port number as well. So the 172.33.1.2, for example, will be assigned 2, and 1.1 gets assigned 3. So you just add a port number to a public address, and that makes it a unique network address. So you can use the same public address over and over again as long as it's got a unique port number. And that's what overload does. So what I'll do is I'll just put this command in that activates port address translation. And I'll go back here. Now it's all configured. What I can do is just send a ping to the ISP server, or ISP router I should say. So I want to ping from host 1 over to the ISP. And I'll make sure the network interfaces are up, and they are. So everything seems fine there. Let's go and verify the configuration is okay. So there's the addresses. So 10 is the link to the internet. That's the outside address, and 20 is the LAN interface, and that's the IPNAT inside address. And there's the NAT pool that's been defined with public addresses, and there's the ACL, and there's the overload command. So what I'll do is go over here and just run a ping. So I'm getting some replies, so I'll try it again. And I'll go to host 2 as well. I'll go ping 172.33.1.254. Getting replies as well. So when I do that, what happens is it activates port address translation on router 1, and I'm actually pinging this inside interface on the ISP router. So if I go to router 1, I'll go show IP NAT translation, and then I get a table here. What it does is it shows, you notice 172.33.1.1, that's the public interface on the outside interface of router 1. It's got these different port numbers. So these are all unique network addresses. It's like they're all unique public addresses because that port number itself makes it unique, and that's what's required. And the 1.2 and the 1.1 get assigned a port as well, and that makes it unique. So the session is unique. And you notice the 1.2 gets 1, 1.1 gets 1. So all these bidirectional traffic flows, they get assigned port numbers, making them unique. And the key thing is, like I said, is with these public addresses, they get assigned a port number, and that's why they you can map hundreds or thousands of private IP addresses to a single or multiple public addresses.